Simplify on the left. Move my 9x over by subtracting. So x is 21. The next theorem I have on the TV, I think it's a little easier for you to see on the TV. And so it says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. Let me draw with some colors because there's so much going on. I think a lot of times when you look at this picture, you see triangles and you don't necessarily see the angles. So what I want to point out to you is what we're looking at here. Here's one inscribed angle. The vertex is on the circle. Here's another inscribed angle. The vertex is on the circle. Both of those angles have the same intercepted arc. So do you see the red angle and the blue angle? They both have the same intercepted arc with that orange. So if they have the same intercepted arc, they have to be the same measure. There's one other one that I want to look at on here. I can also look at it this way. DAC is an intercepted or a inscribed angle, and DBC is also an inscribed angle. They are intercepted by this arc, same intercepted arc. So they're also going to be congruent. There's two sets in that picture. So because they intercept the same arc, the angles are congruent. We're going to use this on our proofs. So the first proof, I want to point out that this is similar. Similar means they're the same shape, but they're proportional sides. You had that on your chapter 9 project at the very last question on a lot of those pages. So we're going to start off by writing our given. We're given circle P, and our reason is given. For this problem, I want to point out that P is the center of the circle. So AC is not a diameter. DB is not a diameter. However, we still have vertical angles. So let's start off by saying that these two central angles are vertical and congruent. So angle AED is congruent to angle BEC, and that's vertical angles theorem. We can use what we just talked about here by saying that there's two angles that have the same intercepted arc. I'm going to use this angle here and this angle here because they intercept the same arc, which means these two angles are congruent. It's a direct application of the theorem that we just talked about. So I can say angle DAE is congruent to angle CBD. And my reason for that is this theorem that we just talked about. There's not a name, so you just have to write it and abbreviate as much as you can. So we can say two inscribed angles intercept same arc are congruent. So because we have two angles that are congruent, that's enough to say that these two triangles are similar. Remember, similar and congruent are different. We're trying to show that they are similar. So now we're allowed to say that triangle AED is similar to triangle BEC. What's my reason for that?
A third angles theorem?
No, third angles would say that because we have two angles congruent, the third set of angles are congruent. This is just angle-angle similarity theorem. Moving on to my last proof. So this one's asking us to show that the triangles are congruent, not similar. This is a different kind of problem. We're going to start off with our givens. Arc AB is congruent to arc CD, and my reason is given. It's marked in my diagram. AB is congruent to CD. Those arcs are the same. So being that we're asked to show that the two triangles are congruent, we need to look at angles. We also need to look at sides. Does anybody see anything that might be helpful? And in this case, this is the diameter. What do you see?
DC is congruent to AB.
Why?
Because of the arrow.
So we know that these chords are congruent because the intercepted arcs are congruent. That was from last lesson. It doesn't have a name. So we can say if arcs are congruent, then the corresponding chords are congruent. And I just abbreviate as much as I can. So we can say that this and this are congruent. What else do you see?
Oh, vertical angles theorem for
Vertical angles. We can say these two angles are congruent. So angle AEB is congruent to angle CED, and that's the same reason we said just a minute ago. Vertical angles theorem. What else do you see? Go ahead.
AE is congruent to EC because of radius.
Okay, in that direction, if we were to write that next, you're correct in that statement that those are congruent because they're both radius, right? In this situation, we would have angle side side, which is not a theorem.
potty word.
So we can't use that one. So we have to go in a different direction. So let's not do that. It wouldn't hurt to put that in your proof, but it's not going to help you get anywhere. What do you see?
AE and EC are both radii.
That's very similar to what she just said. So because these two are the same or these two are the same, you're still going to have that same situation of angle side side. What do you see?
Couldn't you say AE, EC, ED, and EB are all congruent and then side, side, side?
You could do it that way, sure. Okay, so you're saying all of them are congruent, so you want to write it this way. AE is congruent to EC is congruent to BE is congruent to DE. So you're saying all the radii are congruent, and that would be the definition of radius. So what you're saying is this, oop, that should be 3 markings. This, so what's our reason now?
Side, side, side.
Yes. That's a different way to do it. You're correct though. So now I'm allowed to say ABE is congruent to triangle DCE, and what's my reason?
Side, side, side.
Side, side, side. Not the only way to do this problem. You also could have used, wish I had more colors here. You also could have used that idea of what we just talked about with the new theorem. This angle and this angle would be the same because they intercept the same arc. You could have used that one too. You could have done angle, angle, side. Okay?
So is it the same as side angle side?
You could end up doing side, angle, side too, yeah.
Okay.